This is a video explaining how to do number 4 on the moles to mass stoichiometry assignment. So again, it's the same balanced equation as last time. We've got 2 hexanes reacting with 17 oxygens to produce 12 carbon dioxides and 10 waters. If we read the question, it's asking if I do this reaction with 1.15 moles of oxygen, how many grams of water will be produced? So we're going to start off by answering these questions that sort of break down the bigger question they have. So if I do, what do we know? We're looking for the number, and the number is 1.15, and the units following that number is moles of oxygen, moles of O2. What do we want to know? We'll look for the question words, and we see if I do this reaction with 3.5 moles of hexane, how many grams of carbon dioxide? So how many grams carbon dioxide? Nope, sorry, wrong question. How many grams of water? My eyes jumped ahead in the document. How many grams of water? So we're going from moles of oxygen to grams of water. So I'm going to assign O2 to the right-hand side. I'm going to assign this question's substance to the right-hand side, and then this question's substance to the left-hand side. So we're going from moles of oxygen, so that's here, that's moles of oxygen, to grams of water, the mass of water. So we're going down here. And we see to go from moles of oxygen to grams of water, we need to go from moles to moles, and then moles to mass. That's 2 arrows, that's 2 conversion factors. That's going to help us set up this problem here. We'll start with putting what we know as the start to this problem. We've got 1.15 moles of O2 times a conversion factor times a conversion factor. All right, the first conversion factor, the first arrow, takes us from moles of oxygen to moles of water. So we're going to put moles of oxygen on the bottom so that the units cancel out, and moles of water on top, because that's what we're looking for with this first arrow. Now we see that's a moles to moles conversion, that's a mole ratio. We're going to need to look at our balanced chemical equation to figure out what numbers go in those blanks. So oxygen, O2, has a coefficient of 17, so 17 goes with moles of O2. Water has a coefficient of 10, so that means 10 goes with moles of H2O. So we have set up our first conversion factor. For our second conversion factor, we're going from moles of water down to grams, mass of water. So we are going from moles of H2O, and we're going to grams of H2O. Now, anytime you go from moles to mass, you need to find the molar mass, and that means looking at the periodic table and looking at those average atomic masses. So for water, going between moles of water and grams of water, we need to find the molar mass of water. Water's formula is H2O. That means we have 2 hydrogens and 1 oxygen. Each hydrogen has a molar mass of 1.01. Each oxygen has a molar mass of 16. Remember, you can find these numbers on the periodic table. 2 times 1.01 is 2.02. 1 times 16 is just 16. To find the molar mass of water in total, we need to add them up. So 2 plus 0 is 2. That's 0 there. 18. So that means that's how many grams of water are in 1 mole of water. So we will put this number with grams, and we will put a 1 with moles. Now let's see what cancels out and see if we can solve this multiplication problem up at the top of all those fractions. So we're going to start on the left. We see we have, well, actually, let's see what cancels out. Moles and moles of oxygen, those both cancel out. Moles and moles of water, those both cancel out. So we've got 1.15 times, well, that canceled out, so times 10. 10, well, that canceled out, times 18.02 grams of water in the numerator. In the denominator, we've got 17. That canceled out. Divided or times by 1 is still the same thing, so we don't need to worry about that. And that canceled out. So really what we have to do here with our calculators is just take 1.15 times 10 times 18.02 and divide by 17. You can of course do that in your calculators. So 1.15 times 10 times 18.02 divided by 17. I get 12.19 grams of water. Now with all of these problems, we then have to check significant figures. Do we have the correct number of significant figures in our answer? To answer that question, we look back at our starting number. We have 1, 2, 3 sig figs there. We should have 3 sig figs in our answer. So let's start here. This is our first sig fig we get to keep. Here's our second, and here's our third. That's 3. That's how many we had up there. That's how many we get in our answer. So we need to round to the first decimal place, or the tenths place. So that's actually going to make 12.19 become 12.2 grams of water when you correctly round it to the correct number of significant figures.